In this video, we're going to be covering the basics of HVAC. In this box that you see on here, we're going to be looking at the box from the right to the left. So at the top right, they're showing you fresh air in. That's actually going to be drawing air into the vehicle right in front of the windshield. As you're moving down the road, there's going to be a high pressure area that's going to build up in there. So faster you go, the more air it's going to push inside. Down at the bottom is the recirculate. That's where it's going to bring in the air into this HVAC box from inside the vehicle. So when you choose recirculate, it's going to have a door inside there that's going to flip, and it's going to bring in mostly recirculated air, but it's always going to bring in some outside air. About in the center of that image there, there's going to be the evaporator, part of the AC system. There's going to be a door, a temp door, or a blend air door, and then there's going to be the heater core. On the left-hand side, you can see at the top the defrost, or that's going to go out towards the windshield. The vents, they're showing you the two inner vents, but there's also going to be some ducting to bring the air to the outside vents. That would happen at the same time. And then down on the floor for the heat. So the heat, vent, or defrost, and then there's going to be doors that are going to control those. This is a exploded view or a diagram view of that same box that you were looking at. So again, starting in the top right, you can see where the air comes in. There's a door that's default position is down in the A position. But if you hit the recirculation button, that door is going to move up, and then you'd be bringing in mostly inside air, recirculated air, but you see that that door doesn't close all the way, and that's by design to always allow some air to come into the vehicle. If the air was not coming into the vehicle, and you get a small vehicle, like you have people in a Honda Civic, and you put 5 people inside there that are inhaling oxygen and exhaling CO2 without an air supply, you'll eventually kill them. So they design it to always be bringing in some air. Then they have the blower motor, and from the blower motor, the air is going to go to the evaporator. All of the air going into the vehicle through the HVAC goes through the evaporator. Whether the AC is on or not, the air is going to go through that. Then it gets to that mixed door or blend air door or temperature door, depending on the manufacturer what name they're going to call it. Now on this one, they draw it like it's a 3-position door, but this one is actually infinitely variable. So older vehicles, they have a cable that controls it, or they have linkage that controls it. As you adjust the temperature from hot to cold, it's going to either direct the air through the heater core or around the heater core, depending upon whether you choose hot or cold. And then it'll blend to control the temperature coming in. From there, at least on this diagram, they show you the air going to the side windows. That's going to be on some vehicles that they direct some air towards the side windows right, where you would look through to see the mirror to try to keep those clear. Then we get to 2 more doors at the end. The first door on this one is a 3-position door. If it is down in the A position, then the air is going to go past it to either the vent or defrost. If it's in a mid position, that's going to be if you chose for air to go to the floor or to the heater, or for the air to go to the vent and to the floor. And then the C position would be if you chose the heat position, and you'll notice again, it doesn't close all the way. So there will always be some air either going past that door, or even if you have the AC on, some of the air is going to go to the floor. The air that goes past there is then going to get to the last door that's on there, and that one is a 2-position door for either vent or defrost. So depending on whether you've chosen for heat, vent, or defrost, temperature and recirculation, those doors are the ones that are going to control the air movement in the direction it's going to go. So in this image here, you can see the vent, air is coming in, and it's showing you that typically it's by the back door. There's a vent there that allows the air to go out, so you have movement through the car. This is also there so that when you slam a car door shut, that keeps ears from popping while you're inside the vehicle, because it allows the air to move out of the vehicle. On this one, it's showing you for the heat, it's coming out from the floor, and again, going to there. So on these, they're showing you just coming out the floor. On many manufacturers, they have heat vents that come and blow out underneath the front seats to provide some heat for the people in the back seats. Heater core looks like just a small radiator. So those two tubes that you see up at the top, those are going to be sticking through the firewall, and that's where your heater hoses are going to connect up to. The water pump is going to circulate the coolant through the heater core, so as the engine warms up, it's going to warm up the heater core, and that's what's going to provide the heat inside of the vehicle. This one here, you can see a cutaway of it. You can see the evaporator, so air from the fan is going to be pushed through the evaporator, and that air is going to be moving to the left, and there you can see the door that they have, that if that door closes, the air is going to go around the heater core. As that air opens, the door opens, the air is going to go through the heater core, and that, again, that door is infinitely variable and everywhere between there, so you can control the temperature to where you want it. Now, some manufacturers, instead of having that blend door, use this coolant control valve or heater control valve. So this one is typically going to be under the hood, right in front of the firewall, out of the center of the vehicle, so typically behind the engine. And what they're going to do to control the temperature is they're going to restrict the coolant flow through the heater core. So if you want full cold, they just close off the heater core, so heater core gets cold, and then again vary how much coolant's going through there to determine how much heat is going to be allowed to come inside the vehicle. So vehicle gets about 10 years old or so, keep an eye on this piece. If you see coolant on this and not anywhere else, it's starting to leak, you're going to tell the customer they need to replace that valve, because once they begin to leak, they'll fail much quicker. And that small little leak that starts off becomes a pretty big leak fairly quick. Now, if you have a hybrid or electric vehicle, you're not going to have the hot coolant, because you may go anywhere from 1 mile to 70 miles, and the gasoline engine never starts on a hybrid. On an electric vehicle, there is no gas engine. So they're going to use an electric heater. It's going to be high voltage. That's what that orange wire is showing you. So any place that you see the orange wire like that, that's telling you there's at least 70 volts there. So it could be 400 or more, but it's going to be at least 70 volts. So they're going to apply the high voltage to this, and instead of being those elements that heat up and glow like you typically see on a home heater, these are using positive temperature coefficient, or PTC elements. That is, they run current through there, those heat up, and then they're going to have the fan blow by there to bring the heat inside the vehicle. So much more efficient than those home heaters to use these PTC thermistors. The blower motor. So this is typical of what a blower motor is going to look like. You see the squirrel cage fan on the left side of it, and you can also see by looking at it the motor on the right, the squirrel cage fan on the left. That's not a balanced unit, so that squirrel cage fan is hanging off from the side, and so it's going to cause these bushings or bearings to wear unevenly inside there. Once those begin to wear, now the shaft going through the motor is going to be out of alignment. And in a later video, we're going to talk about the importance of that. But that's what's going to be pulling the air inside there. This is called a squirrel cage fan. And if you've had a gerbil or a hamster or something where they run inside of that wheel, that's where the name came from. But they can push a lot of air, and they're quiet while they're doing it. Blower motor speed is going to be controlled on most vehicles by the voltage that's applied to it. Some of the newer ones, they get much fancier with electronics and controlling the speed. Ductwork. I've never had to replace ductwork from being broken. I've had to put them back together where somebody got in there, or sometimes when you're working on them, you have to pull it off in order to get to whatever it is you want to work on. But they're easy enough to put back together, usually. So I've never really had to repair one. The vents that are coming in, people clip things on there, stick things on there, and those break on occasion. Some of them are easy enough to pop out of there and replace. Others of them, they're a pain to try to fix those. So that's it for this video. So to continue this training, you're going to want to look at the HVAC 2 to continue.